Okay, so today we're talking about subtracting with decimals. If I have the number, and I'm on your problem set, number 1, page 1D21, if you want to turn to that. Okay, look at D. 37 thousandths. Is that the right way to do that? No. Perfect, because this is like 30, right? So we don't want that. So we do 3, 7. Do I need to do anything else to that number? Add 0, where? Okay, add a 0 because you can't just leave those numbers hanging. Something always has to be connected to the decimal in order to build out. That'd be like having stairs and missing the first one. You just don't do that unless you want to do a big stretch. Minus 16 thousandths. Seven minus 6. 3 minus 1?
2.
0 minus 0?
0.
So if I were to decompose this number, I didn't want to do that. So how many total thousandths would I have in this number? How many total thousandths?
1.
21 thousandths. Is the same as is that correct? You guys get it written? That was D. Number 2 says solve using the standard algorithm. Can you continue to use your place value chart even though I'm not using mine? So the problem on 2A says 1 and 4/10 minus 7/10. Can you subtract going side to side like that? No, I don't know why they just don't automatically line them up for you. So down below in that empty space, this is what you're going to write. Now let's look at this. Can we take 7 from 4? No, but let's think about what we've been talking about as far as decomposing. 1 and 4/10, how many tenths do I have? How many total tenths do I have? No? Just look at the whole number. 14. I actually have 14 tenths, don't I? And how many do I have down here?
7.
Now can I do that problem? 14 minus 7? What's 14 minus 7? 7/10, right? So actually the decomposing, as far as borrowing and all that, that makes your life a little easier, doesn't it? Now if I were to actually go in here and borrow, I would just borrow from the ones place. That would become 0. So 14 minus 7. Did I get the same answer both times? Yeah, so whichever is less confusing for you is fine. What do you notice about the decimals? What did I do with them? Perfect. I lined up the decimals and then I brought it down.
What you did is basically just the same thing as bottom's bigger, better borrow. Bottom's bigger, better borrow.
Yep, that's a good way to look at it. If the bottom's bigger, you better borrow. Good. Let's try another one. On B. That looks strange, doesn't it? Why does that look weird?
Because the 7 it's not at the very end of the number, it's at like the middle of it.
Yeah, it's like in the middle, isn't it? Because when you subtract, you're used to doing something like this, aren't you? Right? But that doesn't work, does it? Not when you talk about decimals. So what should I do so I don't get myself confused?
Add a 0 under the 9.
Add a 0 under the 9. That looks better, doesn't it? Are my decimals lined up? I'm going to have you solve this problem. If you don't have your clicker right now, you need to get it, and then I'm going to have you click in your answer. And let's see how you're doing. Okay, let's look at how to solve this. 9 minus 0. Can I do 4 minus 7? No, what do I need to do?
You need to cross out that 1 and add to the 4.
Okay, so I'm going to take 1 from this area and add it to this. Remember, every time you go one place over, if I go over this way, what am I adding each time I move over? Each time I move over one place, what am I adding? 10. Because remember the magic number is 10. So if I go from the ones place to the tenths place, I'm adding 10. So then my number becomes 14. 14 minus 7 is, everybody? 7. What do I do with my decimal? Bring it down. 0 minus 0. So that's your answer. Make sure you write it. Problem C. Let's try that one. I want you to click in the answers on that one. See how you do. Okay, everybody, 9 minus 2.
7.
Can't do 4 minus 7, so we're going to borrow. Now we have nothing in that place, and we're going to move it to the right. That gives us 10 more in that space. 14 minus 7.
7.
What do I do with my decimal? 0 minus 0. 9 minus 1. 1 minus nothing. Okay, look at the next problem, E. E is the next one that we're going to do. Now I want you to set it up the way you should, and then I'm going to have you send your answer to me on your clicker. This is a place probably where your place value chart would come in handy. So let's say I'm using the place value chart. Let me pause this for a minute. The place value chart would come in handy because when you go to solve this, just gonna start this garbage. You'll see it's too long. Well, and that's the problem. So let's look at it in our place value chart. We have a problem. What is our problem? Huh?
Minus the 6 and then so that put 0. Thousands on top.
That's right. You are missing something up here, aren't you? You can't just take it from air. I mean, it's like you can't just grab 6 things out of midair. You have to have something to take it from, right? So that's why I've been telling you need to add a 0 anytime there's an empty space. That way you get in the habit of it. What's 0 minus 6? Can you do that?
You go up to the 1.
Go up to that 1. Borrow that 1, right? What does the 1 become?
A 0.
Now I have nothing in this column, but what have I added over here?
A 1.
I've added 10 to what I have, right? So what's 10 minus 6? Everybody? 4. 0 minus 5. Can I do that? What do I need to do? Okay, so I'm going to take 1 from the next place over. And when I borrow 1 from this place, how many am I actually borrowing? So the next place over, I'm borrowing 10, right? So now my 0 is going to become 10. What's 10 minus 5? 8 minus 8. I have another problem. Can I take 2 from 0? No, so I have to go to the next column over and borrow a 10 from the next place over. 10 minus 2 is? We could add a 0 there. 5 minus 0?
5.
So the answer should be 58 and 54. Thank you. I was wondering if you guys were awake still. Number 3 on problem set is written a little differently. You have in A, you have 10 tens. Minus 1. And now everything's going to start messing up on me. Come on. There we go. So you have 10 tens minus 1 10 and 1/10. What's the way I could solve that problem?
Just write it down and write the 110 in standard form, and then write the 10 like under it or over it, and then subtract it.
Okay. What if I pull my place value chart into this again? How many tens do I have? How many tens does it say I have right here?
Oh, 10.
I have 10. How come everybody's hands up? Ten's magic number. So what do I do with that 10? So if I put the 0 in the ones, or I put the 1 here, how many total ones do I have? How many total ones? If I were to decompose this number and scrunch them all together, how many total ones would I have? I would have 10 ones, right? So do you think 10 ones would be the same as 10 tens? Would that be the same? I wonder how you solve this problem. It's obviously an issue because you can't have 10 in one column. So what happens when you get 10 in one column? What happens to the number? What happens when I have 10 in one column? You move the 0 to the ones, but then I'd end up with 10 ones, and I want 10 tens. 10 tens sounds a little lot bigger to me than 10 ones, that's for sure. What do you think? Oh, so you mean if I had, remember like we talked about yesterday? I have 10 dots in there. How many dots does it take before I get to move them over? 10. So I can get rid of these and move them over here. Then how many do I have here? 1. So what would 10 tens be the same as? Huh? 10 hundreds? Perfect. Because think about it, guys. If I have 10 tens, let's say I have the number 100, and I decompose it. What happens when I start coming over this way? How many tens do I have? When I decompose it, how many tens? I have 10 tens. So basically 10 tens is the same as, everybody, what's the same as? 100. So in this problem we have 100 minus what? What are we subtracting? So we have 110 and 1/10. Boy, I would think you would definitely want to use your place value chart for these problems, because that looks like a mess to me. So what do I need in there?
You need a 0.
We're at
In between the 1 and the decimal.
okay, so I need a 0 here. What else do I need?
You need a 0 in the place above the 1.
Okay. Did you have something different you want to add? No. Can I subtract it now? Add a 0 under here. Do we look good now? 0 minus 1. Can I do that? Can I do 0 minus 1? What do I need to do?
You need to back for the borrow. You need to borrow.
You need to borrow. So right now I have this problem written out. And I have to borrow. Can I borrow from my neighbor? No. Because my neighbor is a 0. Can you borrow from nothing? No. Look at the next neighbor. Can you borrow from that neighbor?
Nope.
No. So you have to borrow from the 1. In a situation like this, cross out the 100. I'm borrowing 1 from the 100. Because I can't borrow from 0, and I can't borrow from 0, but I can borrow from 100, right? So what's 100 minus 1?
100 minus 1. Okay, so
Just what's 100 minus 1?
it is 99.
99. So I'm going to put 99 above. And now I've borrowed, right? So I can add 10 here. So what's 10 minus 1? Everybody. 9 minus 0? 9 minus 1?
8.
There's your answer. 89 and 9/10. Decomposing has kind of come in handy, I would say, on several things, hasn't it? Yeah. Let's look at B. In B, we have 3. Minus 22/10. So what's the opposite of decompose, I wonder? Because these numbers are obviously decomposed. This is decomposed. 22 is decomposed. I don't know what the opposite of decomposed is. Maybe uncomposed.
The word is opposite of what you're doing to me. You're
Yeah.
putting them together, so you're
Yeah.
composing them.
So now we're uncomposing. Yeah.
So it's
The verbiage, yeah, the verbiage hasn't made much sense as far as, yeah, because when you decompose, it usually falls apart. So we have it already decomposed, so now you want to do the opposite. They haven't given a word, but I'd say uncompose. That'd be what I am sometimes, not composed.
Why don't you just go and ask this
So what's the opposite, though? What do you do? So what do you do? If the numbers are already crunched, how do you uncrunch them? Look at my numbers. What do you do? Tell me what I need to do. Right here. So tell me what that looks like. So where would they go? Right now I have 22/10. So what do you think? If I decompose, and that means I've taken numbers and I've moved them one place over to the right, how do I get them back to where they were? Where do I need to move them? One place to the left. So if I take off one of my 2's, where's it going to go? To the left. To the left, to the left. Okay, I subtract it. What am I missing? The 0 after the 3. Can I do 0 minus 2? Yep. I have to borrow from over here. This becomes 2, and this becomes 10. 10 minus 2 is 8. So the answer for that problem, letter B on number 3, is 8/10. Can we have you click in this answer? This is C. "37/10 is the same as, what's it the same as? The way to look at this, guys, is it's tenths. How many numbers are behind the decimal when you have tenths? But how many numbers do you usually have behind the decimal if it's in the tenths place? Go ahead. How many numbers are behind the decimal? 1. So that's how you look at it, guys. And if it's in a tenths place, there's 1 number behind the decimal. Right now I have 2 numbers, so I need 1 number behind the decimal, so it'd be 3 7/10. Minus 1 and 2/10. 7 minus 2. Bring down a decimal. 3 minus 1. 2. Answer is 2 5/10. Okay, we'll try one more of these puppies. See if you guys can redeem yourselves a little bit. F. We have 2 1s. 4/10. Minus 59/100ths. Okay, we have 2 1s and 4/10. Well, that would just look just like this. 2 1s, 4/10. What is the rule? What do you have to do when you subtract?
You have to put a 0 at the end because the other number it's too long, so you have to add a 0 at the end of that.
Okay, so we'll do that after we do this one step. What is the step we need to do next?
Minus 59 hundredths.
Okay, 59/100ths. Now when I was walking around, a lot of you were doing this. Does this look like that? No. This number here has to look just like this. So that doesn't work, does it? So what do we need to do? What is the rule that you always do when subtracting? What do you have to do?
The last digit, which is 900, stays the same.
Okay, so 900ths would go in which place? The hundredths. But what's something that might make this a whole lot easier for us? As long as we remember to do this, what do we always have to remember to do?
That is 0.
Eh?
Put the 0 under the 2 and put the decimal. And then put the 5 under the 4 and the 9. And
If we always kept this one rule in mind, we would not have a problem. The rule is you always have to line them up. Thank you. Good job listening. You have to line up the decimals, guys. You were putting decimals in the middle of places that didn't have decimals. You can't do that. Line up the decimal. Now, everybody's been telling me the magic thing that you put up above, and that's 0. Now let's borrow. If you're having a problem with borrowing, there should never be a 9 above a number, okay? Unless you've borrowed from a 0, and you're not doing that in this case. Can I take 9 from 0? No. But you can always look next door and borrow from its neighbor, right? Yeah. So if I borrow one whole of these, how many did I just borrow? How many total did I just borrow? I borrowed 1 from here, but how much would that be in this column? 10. So if you're getting confused, just ask yourself, what's 10 plus 0? 10, right? So 10 minus 1, everybody? 1. Well, this 4 became a 3. What's 3 minus 5? Everybody, 3 minus 5, come on. What is it? Ooh. Ooh, they got me. So what do I need to do with I can't do -2 right in the middle. You got to borrow from the next column over. My 2 becomes a 1. What am I adding over here? What am I adding? If I take 1 from this column, I'm going to add how many to this column? 10. I have 3 there already. Do I get rid of my 3 and just say it's 10? No, what do I need to do? 10 plus 3, that would give me, everybody?
13.
What's 13 minus 5? If you need to use your fingers and toes, then you might need to use your fingers and toes until you can learn how to add and subtract. 8. What's 1 minus nothing? What do I do with my decimals? Bring it down. If you did not get 1 and 81/100ths, you will probably have some extra practice that you're going to need to do, because that's all we're doing with that. So we are on number 4. Miss Fan wrote 3/10. No, 5/10. Sorry about that. 5/10 minus 3/100 on the board. Michael said the answer is 2/10 because 5 minus 3 is 2. Is he correct? I'm going to go through and show you how this would look. 5/10, what would that look like in standard form? 5/10. Okay, so 5/10 minus 3/100, what would that look like? What do I need to put? A 0. So, I have to borrow, right? What does my 5 become, everybody? What does my 0 become? 10 minus 3? 4 minus 0? So that's what 5/10 minus 3/100 looks like, right? Michael said the answer is 2/10. Because 5 minus 3 is 2. Was he correct? No, the answer is no. Because what did Michael forget to do? He forgot to do what a lot of you are forgetting to do. What did he forget to do?
Add 0.
No? What do you think? Borrow? No?
Didn't line up the decimal.
He didn't line up the decimals. Michael forgot to line up the decimals. That is the most important thing when subtracting and adding. Okay, I really wanted to get to this next problem before I set you loose on your homework. Today we're going to use what they call a tape diagram. I like this method. I've used it before when I did Singapore math. It's just a really good method to use. Everybody get that written down for number 4? Because I'm about to erase. Okay, a pen costs $2.09. It costs 45 cents less than a marker. Ken paid for 1 pen and 1 marker with a $5 bill. Use tape diagram with calculations to determine his change. Tape diagram. I kind of introduced you to it a little bit yesterday. So we have a pen. How much is the pen? Okay, so pen is $2.09. Oop. I need to get it off of there probably. And this is the pen. But it says that the pen costs 45 cents less than the marker. So is the marker at least $2.09? Is it at least that much?
No.
The pen costs less than the marker, right? So would the marker be at least $2.09? I would think so. Because we know that the pen is less than the marker, right? So we already know it's definitely $2.09. But how much more than the pen is it?
The marker is 45 cents more.
The marker's, okay, the marker's 45 cents more than the pen. So what do both of these bars equal now? Both of these bars equal? What do both those bars equal? But what do they represent? What item are we talking about? The what? The marker. Well, let's look at this. This may look a little confusing, especially if your eyeballs aren't up here the whole time. Let's look at how this looks. If I were to take the marker, maybe just by itself, and pull it down, is it selecting all of it? That's not going to work for me. Okay, board, do your magic. There we go. Okay, if I were to take the marker and pull it down. Look at the image. Look at the picture. Which one's more? Which one's more? Everybody, which one's more? Marker. The marker. How much more? 45 cents. So if you look at this, you can tell just by looking at these bars that obviously the marker costs more and the pen is 45 cents less than the marker, right? Because it says it costs 45 cents less than the marker. I like these bars. They take a little bit to catch on to, but they're good. But now we don't know how much change he's going to get back. So we have another box because we're not quite sure how much change he's going to get back. How much money did he give him? How much money did he give him? $5. So when you're doing this tape diagram, every single one of those boxes have to add up to $5. So $2.09 plus $2.09. 9 plus 9. 18. Carry the 1. Bring down a decimal. 2 plus 2 is 4. We're up to $4.18. Making me think I'm doing something wrong. Because all of these boxes have to add up to how much money? $5, because that's how much total he gave them, right? And our goal is to find out how much money we have left to get up to that $5. What else do I need to add to that number? What do you think? What else do I need to add? 45 cents. So we've added the 2. Now we have to add $4.18 plus 45 cents. What's 5 plus 8? Everybody? 5 plus 10 is 15. What's 5 plus 8?
13.
I hope that's what you guys said earlier and I just didn't hear it right. 4 plus 1 is 5 plus 1 is 6. 4 plus nothing?
4.
$5 yet. No, but we don't know what that final amount is, so how are we going to find out what the difference is between $5 and $4.63?
Take $5 minus $4.63, and the amount we have left is
So we're going to subtract $5 minus $4.63. Well, I have nothing here. So what do I need to go to borrow from?
We got to borrow some 5.
Borrow from the 5. So this number is no longer 50, but what's the next number below it? What's the next number below 50? 49. And I've just added 10 over here, right? So 10 minus 3 is? 9 minus 6?
3.
How much money does he get back? Everybody?
37
37. And if I were to take all of those numbers and add them together, I would get $5.